Climate. Climate is the average weather conditions in a place over a long period of time, 30 years or more. There are many different types of climates on Earth. Climate zones are areas with distinct climates. They usually extend in an east-west direction around the Earth and can be classified using different climatic parameters. Generally, climate zones are belt-shaped and circular around the poles. In some areas, climate zones can be interrupted by mountains or oceans. There are three major climate zones: tropical, temperate, and Arctic. That is due to solar radiation striking the Earth at different angles depending on the location. On the equator, sunlight reaches the ground almost perpendicularly. At the poles, the angle of the sun is lower on the horizon or even under it during the polar night. So, distance from the equator is important to a region's climate. Distance from the equator is indicated by latitude. The angle from the center of the Earth to a point on the surface is the latitude. By definition, the equator is 0 degrees, so the poles are at 90 degrees. The region between 23.5 degrees north and 23.5 degrees south is called the tropics. It is always warm in the tropics, since the sun is directly overhead during part of the year. The closer to the equator, the more constant the temperature all year. The regions between the tropics and the polar regions are called the temperate regions. The sun is neither directly overhead, nor is it ever completely below the horizon for a full day in the temperate regions. Temperatures vary with the seasons. The region between 66.5 degrees north and 90 degrees north latitude and between 66.5 degrees south and 90 degrees south latitude are called the polar zone. They are relatively cold year-round because they do not receive much direct heating from the sun. The areas around the equator always get more solar energy than the areas near the north or south poles. Even in summer, the north and south poles never get comparable solar energy. It is always much warmer near the equator than near the poles. Click for a video to learn about wind. There is a significant temperature difference between the poles and the equatorial regions. Along the surface of the Earth, cold air flows from the poles towards the equator at low altitudes. As the air moves to lower latitudes, it warms. Near the equator, the warmed air rises and expands. As the air expands, it cools in the upper atmosphere and moves north or south to return to the poles. The net effect is to equalize the temperatures, warming the poles and cooling the equatorial regions. As wind blows south from the North Pole, it's pushed to the right. As wind blows north from the South Pole, it's pushed to the left. The effect is very strong near the poles, and is 0 at the equator. That results in a pattern of prevailing winds. One thing to keep in mind about winds is that they are named for the direction they blow from, not the direction they are blowing towards. This can be confusing, so please remember that, for instance, a westerly wind blows from the west to the east, and a southerly wind blows from the south to the north. In the highest latitudes, the wind starts heading towards the equator, but the very strong Coriolis effect turns it to the west, creating the polar easterly winds. As the wind moves south, it also warms and rises. The westward wind along the surface is shown in green, and the rising and sinking wind is shown in black. Both of these motions occur together. Near the equator, air is warmed and rises. This motion causes the wind to move along the surface towards the equator. Again, the Coriolis effect turns the wind to the west, creating the trade winds. As the wind rises, it cools, begins to sink, and moves away from the equator. The westward wind along the surface is shown in red, and the rising and sinking wind is shown in black. Both of these motions occur together. In the middle latitudes, The winds seem to go backwards. The warm air from the equator that has cooled descends around 30 degrees latitude, creating a high-pressure area on the surface. The cool air from the poles rises around 60 degrees latitude, creating a low pressure. Wind will blow along the surface from 30 degrees to 60 degrees because it has a tendency to move from high to low pressure. The Coriolis effect turns this wind to the east, creating the westerly winds. The eastward wind along the surface is shown in blue, and the rising and sinking air is shown in black. Each of the three cycles of rising and falling air in each hemisphere is called a circulation cell or a convection cell. The convection cells and the Coriolis effect are responsible for the prevailing winds on Earth. Here's another view of the winds sweeping Earth. Continental winds pass over large land masses as they move. As a result, continental winds are cooler than the ocean in the winter and warmer than the ocean in the summer. They are also drier than the air over the ocean. The same global temperature differential between the poles and the equator that drives airflow also drives ocean currents. Warm water from the equator cools and sinks as it reaches either pole. This sinking of cold water seems inconsistent with what we learned earlier, that between 0 degrees Celsius and 4 degrees Celsius, water gets less dense as it gets colder. We learned that's why lakes don't freeze from the bottom. The colder water floats to the top. That's shown on this density graph for fresh water. Water is most dense at 4 degrees Celsius. But the ocean is full of salt water, and salt water always gets denser as it gets colder, at all temperatures. So, as seawater gets cooler, it will always sink through warmer water. This is key to all we will learn about ocean currents. Salt water behaves differently from fresh water as it is cooled. This is a model of the global ocean currents. The red line represents warm currents along the surface, and the blue line represents cold, deep water currents. Atlantic surface water cools on its trip northward. Heat is released to the atmosphere. The water sinks and forms a deep, cold water current that moves back towards the equator. If the ocean wasn't salty, this water wouldn't sink. It takes about 1,000 years for water to complete one cycle. About 100 times as much water is flowing in this conveyor as in the Amazon River. Ocean currents are influenced by a number of factors. Due to the Coriolis effect, currents bend towards the right in the northern hemisphere and towards the left in the southern hemisphere. Prevailing winds direct the warm surface currents, and the ocean bottom and continental coastlines create pathways and obstacles for the water to move through and around. The Coriolis effect, prevailing winds, ocean bottom, and coastlines result in this set of ocean currents.